compressing the stack, and then switches back to programmable telecoms tomorrow afternoon. So this session is securing real-time media and really looking at the overall architecture and APIs that are being defined within MEF to enable that to happen. Basically, that architecture is meant to enable agile, assured, orchestrated network services in general, and works really well or can be applied to securing real-time media sessions across multiple different networks. So the agenda here, first of all, is just to talk briefly about what the problem statement is, introduce you to MEF and to the LSO architecture. Then I'll spend a little bit of time talking about the APIs that are a part of that architecture, and then how we can apply them to real-time communications use case. And then finally wrapping up with what are some of the key benefits that we get as a result of that. I'm happy to have this session be interactive, so if if a question comes up, feel free to jump in at any time, and I'll try to save at least a couple minutes at the end for additional questions. Okay, so our digital economy is really changing quite dramatically. This idea of everything being connected, everyone being connected all the time, really relying on agile and on-demand services much more than we ever did before, whereas before things were maybe more planned and a little more dedicated networks. Now you have much more of moving workloads to the cloud. It's harder to really plan for peak demand times, but at the same time you have the ability to make changes quite quickly because the capacity is out there. You can change the way a network's set up. You start to get those economies of scale. So there's a lot of new problems, but there's also a lot of new opportunities as we're moving more and more workloads to the cloud. And one of the things we're going to talk about is how we want to be able to take advantage of that and make networks and the way that they work for us more dynamic so that this can actually become a good thing. And that's really the overall goal of MEF, is to take advantage of the fact that we have these cloud-based services, but yet still provide the same type of assurance that we came to expect through more dedicated networks that were maybe run on-premise or in your own custom data center or provided by a dedicated service provider. So now we'll take a look at MEF 3.0 and what that is. So MEF has been around for since 2001. First came on the scene developing the market that they coined as carrier Ethernet, standardizing how vendor equipment should act and behave in order to provide carrier Ethernet services, how a service provider, what it meant for them to provide carrier Ethernet services, how multiple service providers could work with each other. And MEF was quite successful in doing that, in defining those specifications and creating a certification program around it, and really helping the carrier Ethernet market grow to the $80 billion business that it is today. So now the idea is, well, we've done that. What are we going to do? What's the next thing? And so the goal for MEF is to kind of move up the stack. If you think of carrier Ethernet as being a little bit more of a layer 2 based service, moving up into layer 3 and even offering higher level services that run on top of that across the network. Looking at network services in general is where MEF wants to start to define new APIs and establish a role for itself and help the market move forward. So lifecycle service orchestration, that's a term that MEF has coined. And what we mean by that is being able to provide services across this new type of network that involves multiple service providers, cloud-based resources as well, and to do so in an automated fashion. And in order to do that, we're going to need some new APIs. A lot of what you see here on this slide, a subscriber describing their intent to a service provider of the type of service they want. That happens today, but it tends to be mostly by calling up and ordering something and human intervention, and it happens on a slower time scale. Similarly, the way that the ordering and billing would happen, or the way that the service would get activated. We're able to do all this today, and it happens all the time, but it tends to be a bit more of a manual process. And so what we're looking to do is to be able to standardize APIs to make all of that so that you can automate it and do so much, much more quickly. And what I'm showing now are these different API reference points that MEF has defined. For each of those services that I mentioned, and for each of these reference points, there's a name for that. You can see the cantata, allegro, legato, presto, adagio. These are some of the interfaces. For those of you who are into music, those will look quite familiar. And you'll see them on future slides. So when you see these terms pop up, you know that I'm referring to the various MEF reference points that are labeled here. But very important is not just doing that from a customer to their service provider and then up and down the service provider stack. A lot of that functionality exists in some form today already. Where MEF really brings its value is enabling service providers to communicate with each other. These east-west interfaces, not just from a subscriber to a service provider, but from one service provider to another service provider, so that you can turn up services that go across multiple service providers and to a cloud-based service provider, for example, or a cloud-hosted solution, and to do those in real time and to do those types of things programmatically. And that's where I mentioned the Sonata and Interlude interface. These are east-west APIs to enable that ecosystem to evolve and to become more programmatic, more dynamic, more agile. So here's the overall framework put together, and I'll be referring back to this slide again later. But the idea is you can see the different reference points here, the different interface reference points that MEF has defined. That's the example of a customer who wants to turn up a service. They could go to a portal. They could programmatically interact with their service provider to see the service offerings that are there. Imagine that service provider doesn't have network connectivity to all of the offices or to all the locations that it needs in order to provide this service. So what it can do then is work with its partners, not by calling them up on the phone or making an arrangement, but rather programmatically to see if they can turn up this type of service that would cross multiple different operator boundaries, multiple different administrative domains, to provide the actual end service that the customer is looking for and all the connectivity that service requires. Yes, question? Sure. Mm-hmm. Yes. No, a very good point, and I don't think I have a slide on this, but MEF realizes that we're not working in a vacuum here, working very closely with partners. TM Forum's a very good example where we have a close relationship with them and actually using the APIs that they've defined quite heavily for this east-west type of relationship because they have a great framework in place there. So working with them on that. The TM Forum's APIs describe a little bit more of a framework for how the API should work without going into the details of like the payload and that. So I'd say we're taking that and then just specializing them a bit more, defining them more fully to meet the needs of this system. Also working quite heavily with the other end of the spectrum with the Linux Foundation and with open source projects like ONAP and with Open Daylight, and the idea being we want to get these same interfaces supported by those open source components so that you can use them to help build out this system. That's another thing we're doing, both to help evolve the spec, but also to provide open source implementations of these things. No. But I can follow up with you on that. So really the idea here, though, is to be able to unlock a lot of pent-up value that's there in the stack at various levels. I already mentioned the carrier Ethernet business that MEF has helped kind of unlock and create a business there. And then these are mostly projections, I believe, because there are future dates on most of them, of additional business opportunities that could be enabled by having this more agile and dynamic way to turn up assured services, not just within a single service provider, but across multiple service providers. And you can see this idea of MEF wanting to provide value higher up the stack for things like SD-WAN, security, application, and really X as a service, as they term it here. So if you wanted to look at the MEF specs where this comes into play, MEF 55 is really the spec that defines the overall LSO architecture, all those reference points, and lays out the way that the different APIs will play at different places within that architecture. Now, key thing here is that it's not just spelling out, not just creating that document, but also creating SDKs, or as I mentioned, working with open source projects to start to provide implementations of all this, and doing that at the same time that the APIs are being defined. So if you go and you look at the MEF specs, you'll see that all of these APIs at every reference point are not clearly defined yet. They're actually evolving. Some, like the Presto and the Legato APIs and the Sonata API, that's one of those east-west interfaces, are a little bit more specified than the others, but they're all evolving as we learn more and as we experiment and as we start to code some of this stuff up and then feed what we learn back into the APIs. So rather than waiting for this whole architecture to evolve over 5 years, we're iterating on it and coming out with releases about every 6 months. So the bad news is the specs and the APIs are changing, but the good news is you don't need to wait till 2023 for the architecture to be in place. You can see the overall vision, and bits and pieces of it are getting built out a little bit clearer with each release. Okay, now I'm going to talk about the real-time media use case a little bit. So similar picture to what we saw before, and making use of all those APIs at different reference points like we did before. The idea being that you could come in through some type of web-based portal. An example would be an enterprise coming in, and from their enterprise network, that's where everything would start. They could, of course, use the north-south APIs like Legato and Presto to do anything they needed to do on their own network to configure it to work well for this secure real-time media use case. And that's what they're already doing today. But then the ability to use the east-west interfaces to talk over to their service provider and to share the information they need to share there about, hey, this service being turned up, and some information about the actual, say, an actual session that's being started up, and for the service provider to be able to configure their network to meet those demands. And at the same time, to be able to reach out to their partners if the other end of this call or someone on the other end of, say, a conference is in a location where they don't have direct connectivity. That can also happen. And again, that's where these east-west APIs like Sonata and Interlude are very key. And then the other bit shown here is you could imagine where this is maybe not an on-premise solution, but it's actually a cloud-hosted solution. And so you need to be able to communicate with that entity and with that domain as well. And these same APIs could be used there. Just looking at it in a bit more detail, the example use case that's being shown here is with WebRTC. And so, again, you could imagine all of this same communication across these different providers happening using these different APIs to set up the WebRTC service end-to-end. And then what I want to be able to show here, and again, I wouldn't get too hung up on the exact flow and the exact things that are happening, but you get the overall idea of the individual that's starting up a session being able to, in this case, start a telepresence call, interfacing in with their enterprise. And that's where, it's typically everything just kind of stops there, right? And you get the service provided by your on-premise service. But what you want to be able to do here is programmatically interface with your service provider so that the service provider is very aware of the session that's happening. And instead of having to maybe decrypt the session in order to figure that out and do some DPI on it or something like that in order to categorize it right, you can programmatically tell them the attributes of it that they need in order to be able to handle it well without breaking into the secured signaling path or without trying to break into the secured media path in order to figure any of that out. Not only that, but they can also talk to their partner providers and share that same level of information that they needed to enable this to work end-to-end as opposed to just within one network or just within another network. Then the other really important thing that this enables you to do is to take advantage of information that you could be learning from the network dynamically as these sessions are going on. And this is where the north-south APIs come into play a little bit more. You can imagine as all this is happening, there's a lot of information that's being determined by the network. And these may be network elements that are very aware of the sessions that are happening above them and know, say, something about WebRTC and the calls that are in place, or they may not know anything about it, but they do know what's going on in the network. They have a lot of statistics there that could be gathered and that could be pushed then up the stack, right, from the network and made available to applications. And those applications may not be the WebRTC application itself, although I guess it could be, but it could be some other application that's going to be looking at all the end user applications that are running and making some decisions of, do I need to shift a little bit more bandwidth to this type of workload as opposed to another workload? Do I want to pay a little bit more to get some, a little bit additional capacity? Is my best effort internet breakout not providing the level of service that I need? And now I actually need to go and get a dedicated, use a bit more bandwidth on my MPLS network that I'm using for, say, more guaranteed traffic. These types of decisions can be made if you're providing the right information and all the information that's needed from the network up to this application and letting it programmatically make changes in real time. And that's another very important use case that the MEF is trying to make more come to reality, I guess, so that, again, as the networks are growing, as you have different players, as you have more things hosted in the cloud and workloads are crossing all these different boundaries, while that complicates things, it also opens up a lot of opportunity, right? Because now you can be much more dynamic. Just like you could have a workload that you host on-prem that sort of bursts to the cloud, right? That idea of like a hybrid cloud type solution. You want to be able to take advantage of those types of things and not to do it based on a phone call that you make to say, hey, there's a problem, but to be able to do it much more dynamically, much more programmatically, and much more automatically. Yep, please. You've been working on ONAP for the last year? Okay. Yes, see, that's a good thing. Yeah. So when there's this thing called the SOF, and I forget exactly what service orchestration function, if that's what the acronym is, ONAP would be fitting in a bit there. I would expect ONAP is going to need definitely to be able to support the Legato API, probably the Presto API as well, and arguably it's very important for it to support the Sonata API. I don't think I see ONAP doing this entire stack, but I would say those APIs probably at least it's going to need to support in some form. If it doesn't directly support, say, Sonata in order to help one service provider talk to another, there may be some other mapping functionality that does that for it. But then once it gets, it must be able to ingest that somehow and then do the right things at the Legato API, certainly, to kick off the rest of the orchestration. Yep. Yeah, and so I don't show ONAP in here, but I have seen pictures, and I'll try to dig up one that I feel is pretty good. It does kind of.
That's okay.
I believe it puts ONAP in here, and it might even put Open Daylight in here as well. But Open Daylight, to some extent, gets subsumed or is a part of ONAP in some of the pictures.
No, it's okay. I just have to do homework. I have to explain this to other people, so that's good. That's all right.
Yeah, and this is there's a lot of discussion happening between TM Forum, MEF, and the Linux Foundation, specifically the ONAP project. And those, to me, are all very, very good things. And but it's the answer just changing and evolving a little bit, I'd say. Okay, so now the key benefits here is that this provides the ability to establish connectivity and bandwidth on demand. And not just within one network, because we're already able to do that, but across multiple networks, right, and multiple different providers. Once you're able to do that and to have a mechanism to communicate from one service provider to another programmatically, you actually get the ability to share information about something like an application, like a real-time media application that's running, and anything you need to share about it, you can share that programmatically as opposed to having to break into the secured signaling, say, to perform some type of DPI on it to figure out how to treat it. You can now do that through APIs instead, a much better alternative. And this whole idea of being able to monitor what's going on within your network and to pass that information up the stack. We've always been able to do that, but doing it programmatically so that instead of an operator seeing that there's a fault somewhere that's having all that information available to a big data platform. Panda is one that I'm familiar with that's used within the Linux Foundation and does this kind of things for network data to be able to draw some conclusions based on what's happening there and then make some changes in real time and observe how well that works and then adjust accordingly. That's another huge, huge benefit. So the way I'd like to wrap up then is to say, without having provided a lot of background to what the MEF does, developing a developer community within MEF is a big goal. Working with like the Linux Foundation on the ONAP project and really getting these ideas tested out and implemented in code is a very important thing. So if you're a software developer, really would love for you to engage in the developer community there. Also, we have the MEF Enterprise Advisory Council. MEF, for those of you who don't know it well, is traditionally much more of a service provider organization. But now you really get this need for enterprise and service providers to work more closely together if you want to make this vision of MEFs a reality. And so the MEF Advisory Council, the Enterprise Advisory Council, is where a lot of that work is happening. And then contributing within the application committee. I'm a co-chair of that committee. Things more closely related to applications like securing real-time media communications across this type of network those land up in the application committee. And so if you're interested in getting involved there, come see me. I can help get you plugged in. Any other questions? Okay, well, great. Well, thank you very much. Oh.
So maybe I spaced it. Do you have 5G specific requirements? Are you working 5G use cases? Does MEF touch slicing? Does MEF touch other building blocks in 5G? Or is this just too far removed from, or 5G too far removed from MEF?
Yeah, good question. I'd say no, it's not off the record because it's being recorded. So 5G is not an area that I personally am actively involved in. There is a group within MEF working on 5G. I can't really speak to those plans. I know it's, and I don't know how clear that roadmap is being worked out as opposed to if it's something that's still kind of forming. But 5G is very relevant to this type of network. It's just, 5G is, if anything, is going to provide another way to plug into this network, right, as opposed to the mechanisms that already exist today, having much more dynamic, much more like IP network type of functionality over cellular networks, to me, is really what 5G brings to the table. So that'll be a big part of this. Oh, I see what you're saying. Yeah. Okay. No, you're probably right. Not an expert there. Okay. Anything else? All right. Well, thank you very much. Appreciate your time and attention.